Hey guys, Mr. Ye here, and we're back with section 2.3 from our textbook, which deals with slope. It's a word I know you've heard before. You're going to hear it a lot again. So again, we're going to go through those basics and maybe go a little bit deeper than you've seen in the past to work some different types of problems. So to start off, slope is a fancy way of saying the rate of change of a line. How quickly is it going up with regards to how quickly it's going sideways? And so if we know 2 points on a line, we can kind of determine how quickly it went up and how quickly it went sideways, and we can find that slope. So we mentioned in section 2.2 that m is typically the letter used in mathematics to represent slope. So what I have written here are a bunch of different ways to represent and calculate slope. The first one being m equals delta y over delta x. Delta is how you pronounce that triangle, Greek letter delta, and it stands for change. So the change in y over the change in x. How much did y change divided by how much did x change? Which is kind of fleshed out in this next one, this next arrow I'm drawing, y2 minus y1 over x2 minus x1. For these 2 points, if we have a point x1, y1, and we have a point x2, y2, then if we subtract y2 minus y1, that'll tell us how much and in what direction did the y coordinate change. And then same with the x's, x2 minus x1 tells us how much and in what direction did the x coordinate change. And so if we subtract those and divide, that will still get us the change in y over change in x. And then I did also include this final kind of just vocabulary, layman's terms definition of slope, and just because it's layman's terms doesn't mean it's any bad. Rise over run, how much did it go up, how much did it go sideways? If it went down, we might represent that as going up in the negative direction, so we'll have a negative value for that change in y, that rise. Couple other basics that we need to talk about before we get into solving problems. Positive slopes always go uphill. They ascend from left to right. Steeper lines are more positive. So in other words, a line with this slope, which is fairly steep, maybe has a slope of 3, whereas a line with this slope, very gradual, has a slope of 1/3. But they're both positive, and it's just the degree how positive is it that controls how steep the line is. Similarly, negative slopes descend, so they go down from left to right, and steeper lines that descend are more negative. So exact same idea. Maybe this guy has a slope of negative 2.5, and this guy has a slope of negative 1/10, but they're both negative, and the more negative one is the steeper line. So first thing we got to do is be able to find the slope given a line, given a couple points on that line. And so we're just going to do that a few times really quickly. Just looking at this before you start any calculations, I want you to be able to look at this and say, I'm expecting a negative slope because it's going downhill. This line is definitely going downhill, so we're expecting a negative slope. So what I'm going to do is I'm going to call this 0.1 and this 0.2. And the truth is it doesn't really matter which one is 1 or 2 as long as we stay consistent. Meaning if this is x1, then this has to be y1. It can't be like x1, y2. So x1, y1, and then x2, y2. So if I'm going to calculate my slope, I'm going to use that y2 minus y1 over x2 minus x1 way of calculating slope that we saw before. So y2 is negative 3 minus y1, which is negative 1, over x2 was 1 is what I have labeled, and minus x1 is 0. Negative 3 minus a negative 1, I'm going to call that plus 1 over 1 minus 0. So negative 3 plus 1 is negative 2 over 1, which lands our slope at negative 2. M equals negative 2. So pretty straightforward, just labeling the points x1, y1, x2, y2, and then plugging them into that way of determining the slope. Again, you're looking at this and you should be thinking to yourself immediately, positive slope. Positive slope, kind of gradual, so it's probably not super positive. And we aren't given the points this time, but if you look closely and I zoom in on this video a little bit, you can see that those points are defined. So like, for example, this one looks like 0, 2. This one looks like 3, -1. Oop, and that should have been a -2. 0, -2 because we went down. 3, -1. So I'm just going to call this x1, y1, x2, y2, and do the exact same thing. M equals y2 minus y1 over x2 minus x1. So -1 minus -2 over 3 minus 0. -1 plus 2 because of the minus a negative number over 3 minus 0, which gets us to +1 on top, 3 on bottom, m equals 1/3. And that answer, again, does really make a lot of sense, seeing as we said it should be positive, which it is according to our calculations, and that it should have a slightly gradual positive slope, and 1/3 definitely fits the bill. It says it's rising 1 for every 3 it's going across, and we can kind of confirm that just by looking at the graph. It rose 1, it went over 3. It rose 1, it went over 3. So feeling good on that one. What about for a horizontal line? What is the slope? Well, the good news is the rules don't change at all. We still know that m equals y2 minus y1 over x2 minus x1. So I'll just call this -2, 2, x1, y1. And then this looks like 1, 2, x2, y2. So let's plug in just the same way we have been doing. Y2 minus y1 over x2 minus x1. We'll simplify that. 2 minus 2 over 1 plus 2. So 0 over 3, and 0 over anything is just 0. The slope is 0. Something to keep in mind, the slope of every horizontal line is going to be 0. Because think about what slope is saying. It's saying, how much does it go up for however many units you go over? Well, this line is not going up at all. It's not going down either. It's staying exactly flat. So it makes sense that the slope is 0 because it's not going up or down at all. M equals 0 for all horizontal lines. All right, last one of this variety. Let's talk this vertical line right here. I've got 2, 2. I've got 2, -1. I'll call this x1, y1, x2, y2. And so if I'm looking for my slope, y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. -1 minus 2, well, I should simplify that, I guess. -3 over 0. And this is where we run into issues. What is the slope of any vertical line? Well, the thing is, it looks like it's -3 over 0, but that doesn't make sense, because if you remember, we can never divide by 0. If I try it on my calculator, -3 divided by 0, it says error, dividing by 0. We can never divide by 0. And so what does this mean? This means that the slope is undefined. It means that the slope, we literally can't say it goes up this much for every, this much it goes sideways, because it didn't go sideways at all. It's only going up and down. So all vertical lines have an undefined slope. And anytime you get 0 on the denominator in that calculation, that's what you know. That's our clue there. All right, so hopefully all that made some sense. Last bit of knowledge for this section has to do with parallel and perpendicular lines. And hopefully you remember those words from geometry. And you might already know this, but I'll refresh it and go over it again anyway. Parallel lines have the exact same slope, but different y-intercepts. I'll just abbreviate there, y-ints. Parallel lines have the same slope. That makes sense because parallel, remember, means they are never going to meet. And that means that if I have two lines like this, they both go up and over the same amount so that they stay constantly that same distance apart and never meet. So parallel lines have the same slope. In other words, in my line 1, line 2 example here, if line 1 has a slope of -2, and we know line 2 is parallel, we know the slope for line 2. If line 1 has a slope of 4, and we know the slope is, and that line 2 is parallel, we know that slope. It's exactly the same for parallel lines. So two lines, if we know they're parallel and we know the slope of one, we actually know the slope of the other. Contrast that to the other P word that is always spoken in the same sentence as parallel, perpendicular. Perpendicular slopes, they are not exactly the same, but they are related. Perpendicular slopes, or perpendicular lines, I should say, have slopes that are opposite reciprocals. Reciprocals, okay. What does that mean? Well, let's start with opposite. Opposite just means if one line has a positive slope, the other one has a negative slope. Opposite refers to the sign, positive, negative. Reciprocal, in general terms, the reciprocal of A over B is B over A. So if the reciprocal of A over B is B over A, we're just flipping that fraction. Opposite reciprocal means A over B should turn into negative B over A for that second slope. So here we go. Line 1 has a slope of -2. So if it's perpendicular to line 2, what is the slope of line 2? Well, this is -2 over 1. We've kind of seen that before, where if there is no written denominator, we can always put the value over 1. So that means line 2 is going to have a slope of opposite, so I know it's going to be positive, and then the reciprocal, positive 1/2. What about this second one? Line 1 and line 2 are perpendicular. Line 1 has a slope of 4 over 1. So that means line 2 has a slope of negative, because we wanted the opposite, reciprocal, -1 over 4. When it comes to decimals, my recommendation is to write these decimals as fractions. And if you're not quite up to kind of speed on that, you know, some of these are simpler than others, I'm going to go back to my calculator. I'm going to show you a really neat trick on graphing calculators. I'm going to type in -0.5, because that's what I see, my decimal. And then I'm going to hit the math button. It's the third row, the leftmost button, right under alpha. And there is a ton of things in these menus, but the one that I love is this very first one that's already highlighted. Number 1, it says arrow fraction. If I hit enter and then hit enter again, it's basically saying turn that decimal into a fraction. And we can see that this is -1/2, which then makes finding the opposite reciprocal super simple. We know it's going to be positive. We need to flip it, +2 over 1, or just 2. And what about 0.25? Let's say I wasn't sure what that was as a fraction. 0.25, math, enter, and it will turn it into a fraction. So this is 1/4. I want the opposite, so negative, reciprocal, 4 over 1, -4. So this is how those slopes of perpendicular lines are related. Now that we've seen that, let's go ahead and work a couple problems, and we'll call it a day. So given the line y equals 2x minus 3, find the equations of lines parallel and perpendicular to it that go through the point 5, 1. So we're looking for two answers, a parallel line and a perpendicular line that go through this point. And we are told to, as a hint, to use point slope form. Makes sense because we're given a point. So let me start with the parallel lines. And I'm going to draw that mathematical symbol for parallel. It's just two vertical lines. That means parallel. What do I know about the slope of my parallel line? Well, I know that parallel lines have the exact same slope. So since the slope of my original given equation is 2, y equals mx plus b, I know the slope of my parallel line is 2. So I know the slope of my parallel line is 2. I know that I have this point, 5, 1, and fortunately, I know point slope form of an equation. We haven't studied it in depth yet, but we did see it on a previous video. It was the y minus y1 is equal to m x minus x1. So I have m is 2. I know that y and x are going to just stay in the equation. So all I need to plug in besides the slope is the x1 and the y1 values of a point on the line. So x1 is just the x coordinate 5 of that point I was given. Y1 is 1. So y minus 1 equals 2, because the lines are parallel, times x minus 5. And that is a fantastic equation of a line parallel to that one we were given. What about perpendicular? There's that symbol for perpendicular. It looks almost like an upside down T. Well, the slope is not exactly the same, but we know how to find the slope of a perpendicular line. It is the opposite reciprocal. So instead of 2, it's going to be negative, instead of 2 over 1, negative 1 over 2, negative 1/2. We're still going through the same point, we're told, 5, 1. And I still know that my point slope form, y minus y1 equals m times x minus x1. So let's fill in what we need. Y minus something equals something times x minus something. I know x minus 5, y minus 1, because those are the two coordinates for the point we're given. And m, we now know, is negative 1/2. So really, it's just a case of using what you know from these equations, a point or the slope, parallel, perpendicular, same or opposite reciprocal, and then plugging in the missing values for point slope form. So if that made sense, and if it didn't, go back, rewind, watch it again, listen again. But I want you to try this problem. Exact same type of problem, but given the line y equals 0.2x plus 1, find the equations of lines parallel and perpendicular that go through the point 9, 9. I'm pausing the video, getting my work down on the screen. You're pausing the video, working this out in your notes as an example. And then when you are ready, go ahead, unpause, and we'll compare your results to mine. All right, so hopefully you had a chance to work those out and your results look like what I got on my screen right now. The one thing I will highlight that was a little bit different with this problem than the last one is the slope was given as 0.2 for the original line. So in order to make my life easier, especially for that perpendicular line, I went to my calculator and I just turned that 0.2 into a fraction. 0.2 turned into a fraction, told me 1/5. So that made it really easy when I was writing my lines. The original slope was 1/5, so the parallel slope in red was 1/5. They match. The perpendicular slope was going to be the opposite reciprocal, so negative 5/1, or negative 5. So we have our slopes. We had the point our line was supposed to go through, so that stays the same. We know our point slope equation, and so for the parallel line, my final answer was y minus 9 equals 1/5 times x minus 9. And for my perpendicular line, I got y minus 9 equals negative 5 times x minus 9. So guys, slope is not a completely new topic to you, hopefully, but maybe some of the stuff we did with parallel and perpendicular lines was. Give it a look. We're going to get lots of practice with this, so make sure you understand it pretty thoroughly, because this is a really good concept to know. As always, if you had questions from this video, let me know. Write them down so you can ask them next time we meet in person. But hopefully this was a nice refresher on slope, maybe diving a little bit deeper than you had in the past, and we'll be able to use these concepts moving forward. So hope this video made sense. Rewind it, rewatch it if you need to, and as always, reach out to me if you need anything. See you next time.